Hello friends, this is first video to understand DSA, that is data structure and algorithm. First of all, let us understand what is meaning of data structure and what is algorithm. And we'll go through few of the topics like this, which is like what is data type, abstract data type, how data structure is derived from there, and how we can do a stepwise refinement to build the program from algorithm or maybe the mathematical model to the algorithm and to the program. So these are the important steps that we will be going through. Okay, so now let us we'll go through this course outline, which is like data structure and algorithm is covered in this video. And coming to the main point, before we get into actually data structure and algorithm, let us first understand or maybe recap ourselves that what are the main ingredients of a computer, which is like how to input or inputting the data or maybe reading the data, and how it should be stored. It should be stored in the memory, all the data and instructions being stored there, and CPU being divided into control unit and ALU. And control unit is something which guides the all the operations, and ALU is doing all the arithmetic and logic operations over there. And at the end, once it is done with all the processing, it will give it the output to the either to the screen or any output device that is required. And again, it takes the guidance from CU to do that one. So these are the important part. And how exactly it works is like through a programming language. Okay, so in a programming language, the constructs are there. Language construct is there, and which converts the program into machine readable instructions, which machine reads like input memory or CPU. All those control unit reads from those instructions and all the data from there, and using those data and instructions, it runs the program there in the machine language. So most important part of this one is that how the programming language construct has been happened, what are the things that is available for data structure, and what are the data types available, and how to write the instructions to carry out all the processings in the programming language. And all together, we will ensure that okay, the algorithm is being built and program has been written, and that program will be processed in the computer after it becomes compiled or maybe interpreted into the machine language. So the next step to understand is what is data structure, what is data type, and what is abstract data types. These are the three important aspect of any data structure algorithm to understand with. So all three sound similar. Basically, it sounds similar, but all are have different meaning. Like data type is like it is it has a set of values associated with it. For example, if it is a boolean, then true or false, two values associated with that one. So it all depends on how programming language construct define those data types. Specifically, they are called primitive data types. Whereas ADT, that is called, we abbreviate that abstract data type as ADT. So which is nothing but a mathematical model together with various operations, okay, defined in the model. Like the operations is like, okay, for example, we will take an example of a set, or you can take the example of a list, or maybe queue, or maybe a stack. Okay, so set is nothing but it is combination. It has the operations that you can make on the set is like union or intersection or size of the set. Similarly, with the list also, you can insert, you can append, or you can add to the end. So list is also a abstract data types. Why we call it as an abstract data types is because it is an abstraction. Okay, it is encapsulate all the operations happen for that particular data type. It happens insertion happens inside. It is not known what is happening inside, but definitely when you do insert, it is a different operation altogether. So it encapsulate that one, and it is a generalization. And also data type all types of data type it can hold. So you can say that one type of like abstract data type is kind of a collection of data of different types, or maybe same type. So that is what we call it as a abstract data types. So data structures usually is being derived from data abstract data type. So to represent mathematical model underlying ADT, we use data structure, which is like arrays, list, okay, record types, all those things. So why it is so important? Like data structure is so important. It is more important because it holds the data, even in the modified form, during the program execution. So accessing the data or reading the data from the memory, it is faster than any other means. Okay, that is why we, because you can hold a lot of data in that memory using data structure. And data structure you use to hold the data in a way, then you can perform all the operations that we just discussed. And also it is the building block, because without data structure, just using primitive data types, it is impossible to write any algorithm or maybe creating a solution around it. Okay, so we will discuss that those things in detail. But the most important part of this one is ATT, that is abstract data types. Our understanding should be clear on that. For example, I'll just show you an example of a list as a data structure, which is like a pointers. One is pointing to four, four is pointing to two. If you look at here, one is there, one is pointing to three, and three is pointing to two, and two is pointing to zero. So these are the one, two, three, four. Those are the this one list is there. If you want to add one, then you can add in between these two, like two or between these two. So it is more of understanding that list as a data structure, how it is represented. Okay, we will see exactly how it works out there in subsequent videos. But this is what is all about data structure, data type, and abstract data type. These are very very critical for us to understand. The reason being that data has always having a data type, whereas the abstract data types, it holds or maybe encapsulates or hides the data types in an abstract form. And when it comes to data structure, it is more of a implementing that abstract data type using some kind of a data types. So that those are the three important factors, or three important terminologies we should be remembering while writing any algorithm. Now we have gone through like data structure, data type, and abstract data type. Let us try to understand what is algorithm. Algorithm is nothing but a set of instruction or maybe sequence of instructions that we will be creating based on the mathematical model or maybe the data structure we have proposed for this particular problem. And once we have that, then we create a solution around it. To make the solution use the data that is being created, okay, that is being modeled, we write set of instructions which is called algorithm. And specifically when writing the algorithm, we write some initially we write general statements, which is like you can say that okay, add two numbers, something like that. But when then we start the refinement of that one. Okay, we refine it using the particular language construct. Usually we start with some instruction, we will do that, we will do this, and these are this sequentially we have to put together. And wherever we have to go through a particular loop, we will mention that here we will go through the data for the data as long as that is there. And once we have done that one, then we'll go to the output, where we will write that okay, here is the output, or this will be going to the file, or it will go to the screen, wherever it is. So all those sequence of steps are being mentioned over there, and that is specifically called algorithm. And algorithm is nothing but what we call as a logic. Okay, that is the logic we are talking about. But the algorithm is kind of a sequence of instructions that we will be executing for the data that we have input. Okay, for example, it is like this. If you look at algorithm simple sample, it is like swapping of two numbers. If you take, I just say that okay, create a temp variable, assign the value to a value of x to temp, then assign the value of y to x, then assign the temp value to y, then end. This is the swap program. Why? What is? Can it be run in any kind of a programming language? No, because this is just simply statements or maybe general statements which has to be translated into programming language. Then only it will be run in that programming language, and that is what we will be creating from algorithm to program, which I have mentioned over here, is that the program is the algorithm as long as it never enters an infinite loop on any input. So to elaborate this, in an algorithm, instruction can be executed any number of times, provided the instructions themselves indicate the repetition. Okay, so it will be repeated. However, we require that no matter what input value may be, an algorithm terminate after executing a finite number of instructions. The important part of algorithm is that you should write an algorithm which is a sequence of instructions, but it should not get into an infinite loop. It should not be remain there. It should come out of that one, because the output has to be given to the file or wherever the output device. So that is the most important part of algorithm, is that it should be a terminate after executing number of instructions. That should be the main motto of that one. And why it is so important? The reason being that whenever you write a program, whenever you wanted to start a solution around it, it is always remember for your note purpose, at least mention that what are the steps you are going to take to solve this particular problem. If when you write those programs, at least when you convert that into any programming language, into any programming language, it will be much easier for you to write, for you to ensure that this is being converted to a program. The and also it is not necessarily it has to be a separate program to be written, but in the program itself you can mention that what is that algorithm is all about for this particular program. Once you write the algorithm, then the below down the line, then you can start writing the program, ensuring that all the instructions in the algorithm is being taken care in the program. So that is why algorithm is very important while writing any program. And the algorithm is contains that mathematical model, which is nothing but at the end of the day what we call it as logic. It is the same thing that we will be creating. Now, let us summarize whatever we understood, how the data structure and the algorithm being used to write for writing a program, step by step approach. So there are three stages. First stage is that creating a mathematical model out of the problem, that is in some kind of a informal algorithm in terms of like general statements. Then use a abstract data type, which is kind of a abstraction for the holding data, and write some kind of a pseudo language program, which is like converting that informal algorithm to a language altogether, programming language, but writing some kind of a pseudo kind of a thing. Like it may not be having complete structure or data, complete program structure basically, or the solution being written probably in plain English. Then comes the third stage, where third stage is the data structure, which is where it is holding the data, actually holding the data, and it will be written in the particular language. That program is written in the particular language, and that should be executable. So those are the three stages. So I'll just go through how it has been defined. Like the first stage is modeling using the appropriate mathematical model such as graph. At this stage, the solution to the problem is an algorithm expressed very informally. So I mean, it's a general statement. Then second stage is very important. The algorithm written in the pseudo language, that is mixture of programming language construct and less formal English statement to reach this state, the informal English is replaced by progressively more detailed sequence of statements. So mostly that English statement has to be converted into a programming instructions altogether. So using the programming language, you start writing instructions like reading the data, for example. Then actually you will write that particular code, how to read the data. Okay, so and same thing like you do some operation addition of two number, then actually you do two addition of two number, and very declaration of variables like you will declare that actually declare those variables as integers. So that is something we have to write actually in the programming language construct. We have to write those instructions so that the machine can understand that. So at some point of time, when this program is sufficiently detailed, then operation to be performed in the various types of data becomes fixed. So we then create a abstract data type for each type data except the elementary data types as the integer and all those things. Those are anyway there, as I told you, integer and all those things being declared at the beginning. But now we wanted to store some of the data we received, like string or maybe integers, into an array or maybe into a list, or we wanted to store everything in a set. We want to create a set out of it. So that's where we have to create all those data structures to hold the data. Then coming to the third stage where we choose the implementation of the data type. So that's where we'll create the data structure. Okay, and we also replace any remaining informal statements into the programming language code. So what we get at the after third stage is the running program. It should be a running program. Maybe few debugging will require, but after that it should be a running program and it will give you the output as necessary. And the whole process is called stepwise refinement, develop, or it's a stepwise refinement, or you can call it as a stepwise development approach. So overall, if you look at the data structure or algorithm, first you understand the problem, then you understand you create a mathematical model out of that one, that what model it will fit into that one. Then you create a abstract data type which will hold the data which we have created out in the mathematical model, and will hold the data. And that particular abstract data type is declared that it will hold the data. And when you come to third stage where actual data structure being created, because it is holding those data inside it, and you will write the program from informal algorithm to the final program, to ensure that this program instructions taking care of the data to process it to give the desired output.